All
We
right,
are
hey you guys,
recording.
thumbs up. Thanks, Wayne. All right, how are you guys doing out there? Thanks for joining us on the Coder School app stream today. My name is Hansel. I am the founder and CEO of the Coder School. Wayne, what's your name?
Well, Wayne is
Well,
my name. Good call out. Good call out. That's the best introduction I've had. But yeah, this is Hansel and I'm Wayne, and we are Coder School app stream episode. Is this a whole hand?
Number five. All right. Well, cool. Well, I am bringing it to you today from our location here at Berkeley. So this is a way back location. Shout out to Lena and Dave who run this location and are kicking butt right now. Wayne, where are you at?
I am all the way on the East Coast, Glastonbury, Connecticut. So that is where I am. Cool
Looks like a
picnic
fancy
table
setup.
behind me.
Love the picnic table. All right,
Love
guys,
it.
let's jump into it. Enough of that marketing spiel stuff. Let's jump right into it. I'm going to share my screen. All you guys go to Scratch. We are, oh, Wayne, you disable me. I need screen sharing, I think. But once
All right.
you
Let me
kids,
just.
why don't you guys go to scratch.mit.edu while Wayne deals with our technical difficulties.
I have just made you the host, I think.
Nice. All right. So now I'm going to share my screen, guys. Let's all go to Scratch and let's throw down. All right, here's Scratch, scratch.mit.edu. We're going to create an AI racer for you guys today. So kind of a racing game where you want to try to outwit and outrace some AI guys. We're going to go into make some AI characters as well. Hopefully you guys will learn a little bit about that. We'll jump into a really quick tech talk on what AI is about. So before we do that, let's just go ahead and hit create. And we're going to just make the basics first and get your cat guy. Your cat guy is your main guy who you're gonna run around this track. So let's run around the track here. I'm gonna go a little bit faster this time in terms of getting this code down. If you guys need to slow down, just go ahead and hit pause. Yeah, let's go. Let's follow along. So
Or you could try raising your hand, but we probably won't be able to see you.
Good. I might sense you. I might be able to sense you.
You might. You might. You could try it.
Who's that? Did somebody raise their hand? All I did is click backdrop. So
that's right. There you go. You're caught up.
You're caught up.
It works. It works.
All right. So backdrops. We want to click on backdrops and we want to draw our racetrack. So you guys can draw whatever you want. What I realized in Scratch is the first thing you have to do here is what we're going to do is draw one gigantic rectangle that is basically dirt color. So how do we get dirt color here? Right around, yay.
Dirt color. Yeah, that's
color.
getting kind of dirty.
There you go. That looks like dirt color. You kids probably know what dirt color is, looks like, right?
Yeah, probably rolled around in it enough.
All right, so what am I doing? I got to click this guy and I'm going to draw a big old rectangle here. And so fill up your whole screen so that it's basically a screen of dirt. Now, let's go do the brush, and we're gonna make a gigantic brush of 100 size. And let's draw the road that we're gonna race on. So in the fill color, we are gonna do gray, which is what the color of many roads are. So do your saturation to 0. That should give you all grays. That just means there's no color to it. I'm gonna pick around 55.
Right, that is good color. Street car racing.
Looks just like a street. All right, so let's go with
Fast and the Furious here. We are doing it. I'm excited.
We're doing it.
Racing
so here we
games.
go.
I love racing games.
So we are going to draw this thing out. So a couple of rules here when you guys draw it out. So draw it out so that it does not intersect with itself. That is very important. It cannot intersect with itself. And it cannot touch the edge of the screen.
Whoa! Yeah. That was pretty close.
That was close. So there you go. So racetrack here, don't touch the edge of any of the screens and don't intersect with yourself and you should be good to go.
That's actually harder. You made that look pretty easy. That's actually
I practice it all day, man. I spend about 5 hours there practicing it just to make sure AppStream is smooth.
Just wanted to point that out. That takes, some special skill.
All right. So like many awesome tracks, we're going to have the color of the middle part of the track, we're going to have this grass. So let's turn the color up to something, wait, and the saturation, let's see. Let's max out the saturation. We'll turn the color to about green, somewhere in there. So that looks like a green. Yeah, let's put it up a little bit. And then we're going to fill the inside. Boom. There's our track. There it is. So
like the Daytona.
Just like Daytona. This is the super Daytona track. So, okay, this is blinking all on me, but okay, so now we need to just go back to the cat. We're gonna rename this guy to Racer 1. Or should we be Speed Racer? You remember that show, Speed Racer, Wayne?
I do. That was all. I keep thinking that they're gonna make a movie out of it. Wouldn't that be
Didn't
a
they? I
great?
think they did.
You know?
I think they did. I never watched
But
it.
I think it was terrible. The movie was terrible. They need to make a good one. I don't even think I saw the movie.
Yeah, they need to ask you to be the star. That's why.
Yeah, that's right. I'd be a perfect Speed Racer. You know,
All right, so
we can show them this.
so our cat's gonna be the racer. The dude is way too big for this road, so of course we're gonna gotta shrink the guy down. So hit looks. Let's set the size to something around, I don't know, 15. Let's see how big he is. Oops, 15. Click that bad boy. Whoa, he's tiny. I can't even see him. All right, let's make him 20. Set size to 20. All right, a little bit bigger. So we're gonna say starting line is, I don't know, right around here. We'll deal with the starting line in a bit. So let's do some pretty simple stuff. You guys might know how to do this already, but follow along if you don't. Basically, we're gonna have him chase the mouse pointer around. Your mouse pointer is gonna be how you control the guy going around the track. So pretty easy.
So it's gonna just basically follow your mouse pointer, right?
That's right. Wherever my mouse pointer is going is where this guy's going. So going forever loop, we are gonna point towards the mouse pointer. And we are gonna move, let's just have him move 2 steps. That in itself should kind of work. Oh yeah.
Oh yeah, just moving wherever you go.
Yeah, but you can run on the grass and you can run on the dirt. That's no good. So what we're gonna do here is, so by the way, there is a reason why the outside of the track is brown and the inside is green. You'll find out a little bit later. But it does need to be 2 different colors. So if you guys didn't do that in 2 different colors, make sure you go back and make that 2 different colors. All right, our man is gonna start racing around here, but we need to get him some guardrails so that if he knocks himself into the grass or the dirt, that he gets punished, gets some punishment.
Negative feedback.
Negative feedback.
Right.
Feedback loop. All right, so we're gonna do an if-then statement inside the forever loop, making sure it's inside the forever loop. We are gonna sense whether we are touching one color or the other. So we're gonna see if we're touching. So if you guys haven't used this yet, use the eyedropper. And we're gonna sense if he's touching brown. And if this cat is touching brown, we are going to basically give him a penalty by saying, "Youch," as if it hurts.
Youch.
Mud for 2 seconds. So he's got to freeze for 2 seconds. That's how code works, right? Sequentially, it's going to freeze for 2 seconds before it goes on. So it's going to freeze for 2 seconds.
And say youch.
And say youch. That's right. That's important.
Youch.
Youch. We also have to move him back a little bit because if he's actually touching the dirt, he's just going to keep touching the dirt. So we're going to have to move him back, let's say 5 spaces.
Great point. I could see that being an easy bug. Like if you were just doing it the first time, you'd be like, "Why is he just frozen?" Saying
stuck on there and keep saying yeah.
He's stuck.
All right, so we're gonna go ahead and see what happens when he hits the dirt. Youch!
Youch! Move back.
Yeah, there we go. That's what we wanted to do. But he's able to run over the grass. So Wayne, what do we do if we want to check that he's also can't go into the grass?
We're gonna have to sense whether he's touching green.
That's right. We're gonna. Green or brown. We're gonna use or. You guys remember that word? Or. Or. It's such a weird word.
If touching green or touching brown, which means he went off into the dirt or he went off into the grass. We're gonna, I guess, either youch and freeze for 2 seconds.
That's right. That's exactly what we're gonna do. Good call.
Move him back.
Go. What? Go back.
Whoa.
Youch. Ouch. All right, so now we got a game going. So now it's a little bit of a challenge. So I actually have to get this guy around, and then if I hit the edge, I get a penalty. But you know what? This guy's too small, I think. This is too easy. I'm going to make him a little bit bigger. So you should make your guy like close to the size of the road. Let's just go 30. Let's see what happens.
Wow, that sounds like it will make it really hard, right? Because you're constantly going to...
Exactly. I like a challenge, Wayne.
And also, could there ever be a case where when you back up 5, you're still touching one of those?
Yeah. But I guess that's a bug we'll have to figure out when we get there.
Okay, that would be interesting. Yeah, if all of a sudden it like gets into a weird corner where it's like backs up 5, youch, youch.
Yep, that's going to happen.
Yeah.
So as part of this game, because we're making a simple version, that probably will happen.
Oh, that's
So
cool.
let's do this though. We're going to do a starting line though, so that we can track when the guy wins. So back to your backdrop, guys. We are just going to do a simple line. We're just going to color in a line, and where's the line? Here's the line. Make it a red line. Red sounds like, I'm already on red. So max brightness, I guess red. Well, if this outline is red, you're good to go. So I'm just going to make it, where should I make the start? Like right here.
Oh, yeah.
All right, now.
Good place.
Back to Speed Racer. Now, if the code for Speed Racer, if I start this thing, oh, wait. We have to check whether we hit the line, right? I forgot about that.
Oh, yeah. We won't know if we ever finished.
That's right. So we got to check whether we are touching...
Binary logic.
Binary logic.
Binary logic. We're going to check something.
That's right.
We're going to do something.
It's true or false. All right, so if it's red, then we're just going to do a really simple thing and just say hello. No, we're not going to say hello. Would you say hello if you won?
No way. Let's say, I win.
I'm going to say, I'm the man. You suck. No, I'm just kidding. We shouldn't say you suck.
That's kind of rude. That's
just
not being very Yeah, it's not good sportsmanship.
That's a good point. All right. I'm the man. You are also awesome.
Yeah, right. That always happens in real life. But, I guess you should shake hands with your opponent and say good match. But
that's right.
Inside, you're thinking what Hansel said the first time.
Okay.
Outside, externally, you are awesome.
So if you win, then we're just going to stop everything. We're going to say you're awesome and then stop everything. So let's see what happens. Boom! I'm the man. You are also awesome. And that stops everything. But that's cheating, though. I started there and I ended there.
Yeah, you went the wrong way, kind of.
That's pretty weak, yeah. So we want to prevent that. So, Wayne, I know you used to do triathlons way back in the day. Do you remember how they make sure that you run the course and you don't just turn around and run through the finish line?
Actually, I was just worried about finishing myself. I don't.
You didn't want to drown?
How did they? I did not attempt to cheat and do that, but I was just worried about drowning myself. So I was focused on going forward. I don't know. Did they have something in place to make sure I could not?
Well, it was a long time ago, Wayne. I'm not even sure if they did it back then. But nowadays, all races have those mats that you run over, right? So you run over the mat, and then when you're out at like way halfway point, you got to run over the mat. So
that is cool.
They know that you actually hit the halfway point. If you hit the halfway point,
there were no mats when I did that.
Yeah. They're just like, that guy is fine.
They're just like, fine. He's all right. He's okay. Now, I was so far back behind anyway. It didn't matter.
So we're going to do that. So that's kind of cool, right, kids? So we're basically taking like a real life scenario, like a real race. How does a real race work? And we're actually going to implement it in code here. So that's the start. That's the starting line. We're going to go back to the stage and we're going to draw a halfway point. So you got to run over this little bumpy thing to make it beep you. And it has to be a different color. So let's tap that thing and make it, I don't know, blue. Let's go blue. Halfway line is, let's say, here. So there's no way to get from the red line to the blue line because of the code, unless you go all the way over the road, right?
Right, because you can't even cut through the green because you're going to get youched and thrown back or
exactly.
Something.
So here's what we're going to do then. So we are going to go back to this cat guy, the speed racer, and we are going to have to set a new variable. Oh, hey, this is a great tech talk, Wayne. We're going to go with, where's the variables? We're going to create a new variable. And this time, guys, you'll probably have never done this before, but let's see, halfway check. We're going to click for this sprite only. Oh, good tech talk. A local variable. Now, why do we need a local variable here versus a global variable? Wayne, what do you think?
Yeah, well, a local variable is usually localized to within a certain amount of code, which usually might be a function. And what you want is where that you can change that variable, but only within that subset of code. And so you don't want other areas of your code changing that variable and messing with it. And that's why sometimes people will localize variables.
That's right. And especially in this case, well, I guess it's not obvious to you guys yet, but we're going to have other racers. And so just
Right.
because I pass the halfway checkpoint doesn't mean you pass the halfway checkpoint. So everybody has to have their own halfway checkpoint. That's why that's
Right.
got to be for the sprite only, which is a local variable. Local meaning it's only local to this cat, as opposed to global, which everybody can look at.
Right. And to the point that Hansel made, so say you had 10 runners when we build even another runner, and anybody passes that, it will reset for everybody, right?
That's
And
right.
so, yeah.
So, okay,
That
so
would
what
be
we're
a
going to do
bug.
is we're going to check whether, okay, so I'm going to copy this finish line code because it's very similar, I think. Duplicate. If touching color blue, so eyedropper blue. So this is checking whether we hit the halfway mark. If it did, well, I guess we don't need to stop all and we don't need to say I'm
You
the
don't need
man.
to say I'm the man. You could say,
You could,
whoo, I finished half.
oh, we could.
You could say
Okay,
something
let's
like
do
that.
that. Let's do that.
Even
So,
when
but
you finish half, that's pretty good.
we want to set the variable so that we know the halfway check to, we'll call it true. True, and then like Wayne said, we're gonna say, I
Halfway
finished
there.
halfway there. Wow.
How it feels good when you know you're halfway there.
That's right, especially in a super long race. This one is kind of
Right.
short, so I'm not sure it matters.
Yeah.
And while Wayne was doing his little tech talk, I actually added these two things up here, and that's because as soon as I hit the green, I want 2 seconds to be able to move my mouse where it needs to go instead of having this guy come towards the green flag.
Good
So,
call. That makes
all right.
sense.
So we actually have this halfway check showing, so let's just test it, see if it works. Oh, oops, wait a minute.
Oh, I'm the man.
Oh,
I'm
wait a minute.
awesome.
Because we didn't change the check. We're touching the color, but we didn't change the check. But of course,
Right.
we need to check that not only are you touching the color, but that you also pass the halfway.
There you go. And that's the reason we put it there, right? We just weren't using it.
That's right. That's the whole reason. Totally forgot why we put it there.
Yeah.
Oh, and it's also, it's not an or. That's dumb of me. And so why?
Yeah.
What's the difference between and or?
So yeah, so in these kind of logic, when you're doing the checks, the and means that both need to be true. And so in this case, they both need to be true. But sometimes you'll do a check and it'll be for something that is just that, hey, if he was touching the red or he was touching that, and if either one of them were true, you would want to then also do that case statement. And so that is very important to be able to use the and, or the or.
Yeah, because we don't want it to end if you hit the halfway check, and we don't want it to end if you are touching the red. We want it to end only when both are true. So that's why there's an and. So let's give it a try and see what happens. Ready, go. All right.
That time, see? It did not think that you finished.
I don't know if you guys think this is fun or not to watch me play, but if you guys have yours, you guys should play yours. We are testing the code.
It's very cool.
Test the code while you're going.
Yeah. I still think, see? Yeah, that's hard because I know you're going to get a lot of youches. Halfway there.
There. Hey, look.
Halfway there.
That's just.
Oh, we did not put the halfway sign away.
Yeah.
So he's halfway there the entire time.
Boom.
Boom. Okay. I'm the man, but I'm also awesome.
That's right. Everybody is awesome. I'm awesome. You're awesome. We're all awesome.
Everybody is awesome.
All right. So that's our main guy. That's how, you know what? I'm going to, here's a little trick for Scratch. I'm going to move this guy here. And once you move him there, that's his starting point. Once you move him there, you can go up to motion and this is pre-filled out for you. Actually, one of our franchisees taught me this, John in Sarasota. That's pre-filled out for your -40, -32 is actually right there. So we're going to start him there every time you hit the green flag.
You could change the halfway there to end after 2 seconds too. If you want.
But then he would freeze there for 2 seconds. So I'm not sure.
Oh, that's true. So maybe, yeah, that's interesting.
So we're not going to mess around with that. You can.
You don't want him to be free. Yeah,
other stuff.
You don't want to pause because other racers will be catching.
Yeah.
But yeah.
Okay, so now's the time for another racer. All right, here we go. So we are gonna do our AI racer. So what? Okay, so let's choose another sprite, guys. So we're gonna go into animals because of course animals race animals. That's the only way it goes.
That is animals the typical race. Yeah.
So let's go with dog. We love the dog.
Ah, there we go.
Wow, doggy is huge. Let's start the doggy here. We're gonna go to the shape.
He's touching everything on the sensing.
That's right. He's gonna be going
He's
backwards all day long. So let's change
touching
his dog
green,
to
touching brown.
20%. Yeah, tiny little dog. Actually, we'll give him a little bit of
That's reasonable.
15%. We'll give him a little more breathing room. All right, so here's what we're gonna do. I'm gonna do a quick AI thing, and then Wayne will explain some awesome terms for you guys to know about AI. AI is a huge buzz term right now, so you guys should know a little bit more about it. All right, so let's just build this guy out. So we are gonna say when the green flag is clicked, the dog is going to move. Whoa, hold on, I can't move him yet. I'm gonna go forever. It's gotta be a forever loop. The dog is gonna move, let's see, I'm gonna say 3 steps forward. And the trick is if they are touching, if the dog is touching the green, so this is where the AI comes in, folks. So, and this is why we need 2 different colors. If touching color, we're gonna go to the green. If touching green, then we actually want the dog to turn a little bit to the right. So think about this test, kids. If you guys go into your hallway, let's say you have a hallway at home, and you close your eyes and you hold out both of your hands, and you're just gonna walk along. If you hit your right hand, you'll know that, okay, well, I better turn left a little bit. If you hit your left hand, okay, I better turn right a little bit. It's kind of what this is doing, except for the dog has no hands. And instead of using hands, we're using colors. That's why there's 2 different colors. So if the color touches the green, we are going to, because it's touching the green, we got to step back a little bit. So whereas in a hallway, you're just going to turn, the dog actually have to step back a couple of steps and then turn. All right, so we're going to move back minus, I don't know, 4 steps. And what do we say? We got to turn right, I'm guessing.
Yeah, from the green, you would probably turn right. Yep.
That looks right. Okay, well, before we test it, let's do the brown. So I'm gonna duplicate this code, throw this bad boy in here. Oh, hey, whoa. It's running off the screen. I better drag him back. Okay, so before I do that, I'm gonna do brown here. This guy ran off the screen. Now we want to move -4, and then we want to turn, instead of turn left, we want to turn right. Wait, is that right? No, instead of turning right, we want to turn left.
Well, yeah, we want to go left.
I can either do -15 here, or it looks a little bit cooler if I did this way, I think. Or it's
more intuitive, right? The arrow, yeah.
All right, now if this guy goes, then you're ready for Wayne's AI talk. Look, it's totally AI.
Look at that.
I'm not moving the guy at all, and he is racing for you.
Yeah, so I don't know if you guys have heard the term or the phrase artificial intelligence. Most of you probably have. There's movies and things, Arnold Schwarzenegger's The Terminator. So these are machines that have been given intelligence. So artificial intelligence is a lot like what it's meant to say. It's you know, artificially giving intelligence to a machine.
I'm giving Wayne the clock because everybody has 2 minutes to do the tech talk.
That's right. So I think I'm at I'm halfway there. I want my halfway check thing. I want the halfway. So anyway, there's a few levels of it. So if you go a little bit further, there's what you call machine learning. And that's when you actually have the machine is able to learn. So it doesn't just do exactly what you're saying based on those rules, but it actually, given inputs and data and information and given certain rules, it can actually start to learn itself. So it doesn't have to be told everything. And
in
so
our code here, this is just basic AI, basic artificial intelligence, because there's a couple rules that we threw in here. But like Wayne said, there's this next level of advanced AI, which is called machine learning. This is not machine learning. Machine learning.
Right. Yeah, and then you can take it one deeper step called deep learning in that deep voice. But it's just much more intense, and it's when you give the machine some very complex algorithms similar to a human brain, the cognitive thoughts and algorithms that we use to learn. And so then when the computer has a bunch of information, it's looking for patterns, how humans look for patterns to learn things. So it's not just so straight up rules like, I before E except after C. It's actually simulating a bit of the human cognitive learning ability,
Yeah.
and that's
Here,
very complex.
here, I'll give an example. Wayne, say it as fast as you can. What am I drawing?
Circle, a cat.
Cat.
Yeah, cat.
How did you know so fast?
Because I am deep learning in the brain, and I've seen those triangle, ears, and so I just know the pattern. I know the pattern, and so I could do that. And for a computer to be able to recognize that, you would have to program some pretty intense artificial intelligence at some lower levels.
Yeah. That's why that deep learning is so dang cool, because you can, the computer can learn so much that you don't even have to give it, you just have to give it a lot of data and a lot of computing power. And it can learn a bunch of stuff that you don't even know.
Yeah.
So there's a whole science about that. And if you guys are interested in more, go ahead and check in Google. But the 3 words you guys should know, artificial intelligence, it's just basically having a computer simulate intelligence, which is actually what we're doing right here, a very, very basic. The second word to know is machine learning. Machine learning is where the machine actually learns. You don't have to give it every single case. It'll just kind of learn over time. Deep learning is like machine learning, but super machine learning, where you give it tons and tons more data and you use tons and tons more computing power to get you a lot better results. That's probably the best way to explain it for now. So hope you guys remember those words, throw them out at your parents every once in a while to impress the heck out of them, all right?
Definitely. Or just watch The Terminator and you'll know where all of it will lead.
Which is a scary but awesome movie.
That's right. That's right. What was the computer that Skynet? I don't know.
Skynet.
Like that.
That's right. Skynet destroys the world. Okay,
there you go.
So here we are. We are back to our app now. So we got the doggy who is running around, and we have to do the same kind of check. So let's just do the halfway check with me, guys. We're going to go to the variable, and so notice that the halfway check for Speed Racer is not here. That's because the dog can't see it, because it's a local variable. We need to make the same halfway check.
For the dog.
For the dog, that's right. And don't forget to check for this sprite only. It is a local variable. So we will see that it is not true, and so we have to set it to true, just like we did with the cat. And when do we do that? We do that when we touch the halfway line. So ding, 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 blue, and set. Where's my set? Set halfway check to true.
True.
Now, anytime you guys set a variable, so you can see halfway check is true already. With Scratch, especially with Scratch and probably other languages as well, pretty much anytime you set a variable, you pretty much better remember to reset it, like when you start. So
good tip. I often forget that. I think programmers, you could be programming forever, and it's an easy thing to forget.
Yep. So we're gonna set this guy here. So make sure to set. Well, it's already 0, but we're gonna set it to 0. So let's just test it just to see if it works. Green flag. Let's see.
Whoa.
So it hit true, and my guy is still running around because I was clicking around. So that actually worked. Now, finally, let's go back to the cat real quick so that we can set the halfway check, because I forgot to do it here. Set the halfway check to 0. And the last thing is this "you are awesome" thing.
Thank you, Hansel. Thank you.
What's that? Yeah.
You said I was awesome. Thank you.
You're welcome. You're welcome. It's implied. Every time I say it, it's implied. We're going to use this backpack. We're going to use this backpack, which we haven't used before. Hey, I already have something in here. Well, it must be from my testing before. So I'm going to take this code here, and I'm going to duplicate it. Can I do this? I've actually never tried this. Duplicate it and stick it on my backpack. I think I can do that. Yeah, I can do that. Okay, so put it in your backpack means I can put it here and then go over to the dog. It's kind of like a cut and paste, copy and paste.
Like a clipboard area.
Like a clipboard area, yep. That's what they call it in a computer, yep. So this is too much stuff because we've already done the halfway check. So now we are gonna stick, it doesn't matter where you stick this as long as it's outside the if statements and inside the forever loop. So if touching color, I guess we will say that, we'll just say I win. So the dog will say I win, whereas the cat will say, you're awesome, Wayne.
Yeah, that's right.
And let's uncheck this halfway. Let's uncheck this halfway stuff so we don't see it. Oh, one last thing. for the dog, let's make sure the dog starts right there. We want to blink it there every time we hit the green flag. So let's see, where's that emotion? We are going to go to, and it's pre-filled out already.
I like that. I like that pre-filled out.
Yeah, so when we start, we're going to go there and we are going to point in direction 90. Okay, so here we go. So wow, that's a lot of code actually we dragged in there. So this should work.
Actually, that is a lot of code.
I'm going to run this thing,
hefty.
and the dog is going to start going while I'm counting. But here we go. Now it's
hey, he got a head start.
Oh man!
Oh man!
Okay, here we go.
Dog going in circles.
Hey, why is the dog? Oh, so the one thing when you're making a game, guys, is that sometimes you make, the reason I made the cat bigger is to make it harder for me. But sometimes what happens is you make it so easy for you that you always win. That's no fun, right? You want to make a game that's pretty fun to play, because sometimes you win, sometimes you lose. Why is the dog flying all over the place?
Sometimes, well, that would go back to the artificial intelligence tech talk. It's not as artificially intelligent as we could.
He's
program.
Gonna win. But, oh, except for he's spinning in a circle. Yes. Oh no.
Yeah, he's caught in a circle though.
Oh no, he's out of here. Yes.
Oh, yeah.
No, I win first and then he won.
Yeah, well, you both won. I guess that might be another bit of logic you could code once one person wins.
Yeah. So, so you guys saw that sometimes the dogs fun around in circles. That's because this is about the most basic AI you could have. In fact, it's only 2 lines, which is pretty
right.
Cool. So usually it's like a gigantic page of logic. So,
right.
All right. So we got that going, but you know, dogs and racing cats, that's fine and all, but it's not cool unless you get the clone, right? Everybody loves cloning. So here's what we're gonna do, guys. We're gonna clone the dog and make a bunch of dogs that we have to race. So let's see, let's move this code here, and we are gonna clone, where's clone? Let's see, when I start as a clone, we're gonna do all this stuff, and we are going to do, I'm sure somebody out there is going to do 1 million clones, but we're just going to do 3 clones.
Yeah. Well, the track will get quite crowded very fast.
All right. So this is pretty easy. When I click the flag, going to go with 3 clones. They are all going to pop up right here, and they're going to start going. And something interesting should happen. So look at those. There's actually 3 dogs. So you can ignore the cat, but 3 dogs who are going pretty close to the same place. 2 of them are following each other, and now they're spinning in circles.
Yeah.
They're following each other. One guy got away somehow.
Oh, yeah, there.
Got away, which is interesting. I didn't think that was going to happen. And the reason is because the way computers work is whatever input you give it, it has to follow the same thing every time. We didn't give any random numbers in here. So all the clones started here. All the clones are pointing in the same direction. We have the same exact track. So I actually would have expected this thing to all do exactly the same thing.
That's what I was thinking too, that we wouldn't even be able to see the 3, that they would like all 3.
So, oh, you know what? The one guy always breaks off here, and let's see if another guy always breaks off up here. So it must have to do with they are off by like a little tiny bit or something. But they're off by a bit. I'm going to run it one more time. And you'll see, let's see if the first one breaks off right here. The first one breaks off right here. So it runs the same way every time. It looks random, but it's actually not random. They actually go and run through the exact same thing every time, which is interesting.
Yeah.
So so why is that, Wayne? Why do computers run the exact same way every time?
Yeah. So if you want to just know one thing about computers, they're deterministic. And so by deterministic, it just means that, I mean, they can't truly be random in a pure sense. They have to be running by, you know, a certain pattern based input. I'm going to do something, and they have to always do something that was predetermined. So computers, interestingly, they have those random number generators. The number will never be, in a pure sense, true random. They'll be random enough for most purposes, though. And so that's why plenty of people use them, and they work fine in most programming languages. But just so you know one thing, a computer cannot create a true random number. It's because of its deterministic characteristics.
Yeah, that's a big word for you guys, deterministic. The opposite, what's the opposite of deterministic? Who knows? Who has taken stats out there? The
Yeah.
opposite of deterministic is stochastic. You don't need to know that, but it's kind of a cool word to know, stochastic. You can say
that
it.
Is yeah.
Stochastic. It means
if you can say those two words, deterministic and stochastic, in the same sentence.
Yeah, and it's not sarcastic because it sounds like it.
Yeah, that's right. It sounds like it. That's an easier word.
So Wayne and I, we're people, so we're stochastic. So if Wayne said to me, move 5 steps, all right, today I'm going to move 5 steps. If he said it to me again, I'm going to move a little bit further than 5 steps because I just had coffee. Tomorrow I'd be like, Wayne, why are you so bossy? I'm not going to move 5 steps at all. I'm going to move 4 steps. But a computer, you tell it to move 5 steps, it's going to move 5 steps, the exact same 5 steps. That's why computers are awesome. That's also why they kind of are frustrating sometimes. They do the exact same thing. That's why when you do a random number, it's what they call a pseudo-random number. It's not really a random number. So just a little bit of trivia for you guys. But you saw that I actually pick random number here so they're pointing in different directions. A random, pseudo-random direction. Pseudo-random is pretty much random enough to us where it pretty much
that's right.
It's pretty much random.
Yeah, right, so it's kind of as a very, it's a very fine difference. Yeah. And so it's just something for you to know, but people are always using random number generators in their code.
So if I hit go now, in theory, these guys should look like 3 different entities kind of running around wherever.
Oh, yeah.
There we go.
The dog track.
Yep. All right. So let's make this a little bit more exciting. We're going to go, well, first of all, actually, you see how this guy, no, let's do that a little bit later. Okay, let's go to the dog track. Let's not go to the dog track. We're going to go to the dog's costumes. Let's delete this costume here, and let's just have this guy race against a bunch of different animals. So we're going to choose a costume, pick whatever animals you want to pick. I'm going to go with butterfly because that seems to make sense. I don't know.
Yeah.
And
sort of makes as much sense as it would anything else. In a stochastic way, in a stochastic random way.
In a very stochastic. We should keep using that word now. See how many sentences we can use stochastic in.
That's right. In a non-sarcastic but stochastic way.
Non-sarcastic but stochastic. Okay, so here's 4 different animals. Go back to the code.
I'm pulling for the underdog. Who would the underdog be? Who do you think?
Probably the chick, the cutest thing.
Exactly, because I'm an underdog. I always root for the underdog. I'm hoping that the chick somehow pulls it out. So
all we need to do is do the next costume, and that should have a couple of different dudes running around. What? Next costume. Oh, you know what? I need to give the next costume to this guy.
You didn't, yeah.
Now let's try it.
Huh?
Now we got, wait, why do we have 2 dinosaurs? Oh, no, we don't. We got a butterfly underneath the dinosaurs running about the same place. You know what? Those guys are running about the same place. I'm going to do a different random thing here. Instead of a random direction to start in, I'm going to do a turning random. Ooh, that should make
that should make it really wonky. And some are probably going to go backwards for sure.
Something weird's going to happen here. We're going to see what happens. So 12.
I'm hoping that poor little chick. I'm hoping the poor little chick finds its way.
This should look a little bit more realistic. The dog went backwards. So that's one thing.
Totally in the wrong. Okay, it's moving now.
All right, here we go.
Butterfly and that chick kind of follow each other around a lot. Oh, my chick is winning.
Chick is winning. Yeah. Chick is winning. All right, so now we got a bunch of different guys, but you notice how the butterfly is still chilling out right here. That's because the butterfly is the original clone. It's the main dude who had the clone babies over here. So once this guy is done doing a next costume and creating a clone of himself, it actually is done. The main guy is done. Because it's not going to run this code because it's not a clone. It's just going to run this code. So there's 2 ways to do this now, actually. So one way is I can just do a duplicate, copy this entire gigantic block of code and put it under here. And if we do that, you'll see that they all kind of started over here. We got 2 dogs, I guess, but let's see. That's probably because I didn't do a next. Oh, I should do the next costume up here. I'm going to do a next costume. No, that's not going to work. Let's see. I'm going to do, why does it do that?
Oh, do we not have enough costumes? So it loops
Oh,
back?
that could definitely be. That could definitely be.
Yeah.
There we go. Here we go. Okay, so I put it in the right place. The next costume is after the clone. So, all right, so we got four things running around. So, but that looks a little bit messy here. Wayne, what is a good way? So this is the exact same code as this code.
Yeah, look at how much code that is, and it's so ugly. So you could use a function here, which would be a nice little way to save all that code being written double. And sometimes, you know, the purpose of writing a function is when you want to use a block of code, like that whole big block of code, and you want to use it again and again and again. But you don't want to copy it all over and have it all over. So you just, you put it into a function, and then just by calling the name of the function, you can call all that code again. And so it makes it really easier.
Yeah, it'll run all the code inside. And so Scratch actually doesn't call it a function. So if you guys are thinking, how come there's no function here? That's because Scratch doesn't call it a function. They call them blocks. So most languages don't use blocks, but Scratch does. So you make your own custom block, and this block basically has all this code in it that, like Wayne said, will run every time you run this block. So this block name, we are going to call it, wait, what are we calling it? We are calling
what
it.
What are we going to call it?
Clone
block
racing.
Name 1.
Block name Rust. Always call it something that you can recognize. Remember that, guys.
Yeah.
Now, there's a bunch of other stuff that you can do to it, but we're not going to do anything interesting like inputs and all this stuff. We only need it to run the same thing, exact same thing every time. So we need to define it. What does that mean? It means what it runs when you run clone race. So we drag all the code in here. So when we run clone race anywhere, it'll run everything in here. So here's the block. We made a block. So all we have to do is put one of them here and one of them there. And we should
put it wherever you want. Yeah, and you can use the functions as much as you want. And that's the beauty of it.
Yeah, yeah. And there's a lot more you can do with it. That's very much tip of the iceberg. So this way it'll start as a clone, and the guy itself, they'll both do the exact same code. Let's see if that works. Yeah, pretty much. And the dog is, of course, running backwards again. I'm not sure why the dog.
But he usually picks it up around now. He usually figures it out. There he goes.
Everybody's going like at the same place. I don't like that.
That's true too. Yeah, I don't know why they're not changing. But you know, one other benefit of a function is that when you want to change your function, you can just change it in this one place, and then it will change everywhere. Whereas if you did have it in 3 different places, you're going to be making that same fix in 3 different places.
That's right. That's exactly right. All right, so we're going to have it be much more random and a much wider range of how much it turns. So let's see if this makes any difference. Barely. But a little bit. I mean, they're all kind of racing around. So there you go, guys.
Now they're kind of racing around and doing some different stuff. And look, some people are even taking different leads.
Yeah, now it's the weird red dinosaur guy.
Yeah, but the chick's gonna catch him. Come on.
Come on, chick.
Oh.
Come on.
Man, the dinosaur is just going straight for the
boom.
Boom. Boom, boom, boom.
There we go. There's your game, guys. So build your own game and make it so that, well, I guess I suck at it, but.
Oh yeah, you're getting loud.
Whether you would beat the computer or not, and you'll have a really fun game. So I think that's it for today. That should hopefully give you a quick lesson in AI and make you a little cool little racer game. I guess that's it. I'm Hansel, founder and CEO of theCoderSchool. This is my man Wayne, also named Wayne.
Yeah.
This is Dave. Hope you guys had a good time. We'll see you guys next time. Happy coding.
All right. Happy coding.